All right, the width of a poster board is 40 inches. Using scissors, you reduce the width of the poster board to 10 inches. What is the scale factor of the dilation? All right, so it's important that we note that we're reducing it. We just said on the last video that if you're making something bigger, the scale factor has to be greater than 1. If you're reducing it, the scale factor has to be between 0 and 1. So that's a quick way to double check yourself, and if it's multiple choice, it's a quick way to eliminate answers. Because we're reducing it, we know anything greater than 1 can't be an answer. So if it says 2, 3, 4, whatever, none of those can be answers. We know we're looking for a number between 0 and 1. So if we take what we ended up with and divided it by what we started with and just reduce this, we would get 1/4. That's our scale factor because we're making it a fourth of its size. We started with 40, we ended with 10, so our scale factor is 1/4. If you Well, never mind. That's all you need to know. Using the scale of 1 inch is 15 feet, if the dimensions of the blueprint are 0.5 inches by 1.75 inches, what are the actual measurements? So using our scale, it says 1 inch is 15 feet. So we're just going to multiply each of these by 15 to get our actual measurements. So let's go to our calculator. 0.5 times 15, so that's going to be 7.5 feet. And then let's do this one, 1.75 times 15. And that's going to be 26.25 feet. And I just put this X here because that's usually how you write by, like if you're doing measurements, you usually do like this by that. So those would be our actual measurements. And then it says, what are the blueprint's dimension of a room that is 30 feet by 45 feet? So now we're going in the opposite direction. So instead of multiplying, we are going to divide. So we're going to do 30 divided by 15 and 45 divided by 15 to get it back down to inches. So this would be 2 inches by 3 inches. That would be the measurements of the blueprint. So if you're going from the small to the bigger, you want to multiply. And if you're going from the bigger measurement to the smaller, you want to divide. Let me go back and... Okay. For this one, the coordinates of triangle ABC are given below, right here. Find the coordinates of the image after a dilation with a scale factor of 3. The scale factor tells you how much you're making it bigger or smaller. In this case, since the scale factor is greater than 1, we know we're making it 3 times bigger. So all we're going to do is we're going to go over here to each of our coordinates and we're going to multiply all of these by 3 to get our new coordinates because we're making it 3 times bigger, so we want to multiply by 3. So our new A prime, -2 times 3 is -6, 4 times 3 is 12. And now let's find our new B prime. 2 times 3 is 6, 4 times 3 is 12. And then to find C prime, 0 times 3 is still 0, -1 times 3 is -3. These are the new coordinates of the triangle that is now 3 times bigger. Are these polynomials similar? Why or why not? All right, for them to be similar, their sides have to be proportional. So we're going to find their corresponding sides and we're going to set up proportions and make sure that they are proportional. So like I'm just going to go ahead and color code these. Those two go together. 5 corresponds to 10. 2 corresponds to 4. And 3 corresponds to 6. So let's set up all of our fractions and see if they are proportional. So 1/2. If these are similar, that has to also equal 5/10, which has to also equal 2/4, which has to also equal, and you have to check every single side. Oops, I kind of wrote over that. Oh, 3. Okay. Has to also equal 3/6. So let's just make sure all these fractions are actually equal. 1/2, we can't reduce that. That's already reduced. 5/10, if we reduce that, 5 divided by 10, that also equals 1/2. 2/4, that equals 1/2. 3/6. let's just double check. They should all equal 1/2, which, of course, most of you probably know this already. But they do all equal 1/2. So these triangles are similar. So let's go ahead and write down, if we were having to write this answer, we would say, yes, these triangles, not triangles, polygons, geez Louise, are similar. I'm cracking up that I said triangles, because all of the corresponding two R's. Okay. Because all the corresponding sides are proportional. They all reduce, to 1/2. All right, this is not always the case though. Sometimes you see a problem like this and you go to check the fractions, and so you label the corresponding sides and you go to check and you see like these first two, they both work. Those both reduce to 3/2, but then the last one doesn't. It reduces differently. So since these do not all reduce the same, these are not similar. So I wanted to kind of show you one of each type. If all of your fractions reduce to the same thing, it is similar. If not, then it's not similar. Okay, and that's it. Make sure you go back over all of this, and good luck on your test.